Okay, perfect, thank you. So, hello, my name is John Burroughs. I'm a solution architect with Trend Micro. And today what we're going to talk about are some of the security challenges organizations have with their virtual data center and their journey to the cloud. Once we talk about the security risks, then I'm going to introduce two of our products that we have to address those. And if you have any questions, please let me know. Or we also have a booth here with our partner, our distributor, Arrow ECS. You can ask us afterwards as well, too. And also, my colleague over here has a survey. And if you wouldn't mind answering it, he's going to hand it out. And we'll have a quick draw afterwards. We just have some USB tokens as well, too, to give out. And just to give us a little bit of feedback on what you're doing in your organizations. So what I want to talk about is that as a company makes its journey to the cloud, there's obviously the three platforms that are involved. There's the physical platform that we know about. There's a virtual platform, whether that's desktops or servers. And there's the cloud platform, whether that's the private, public, or hybrid. The thing that I want to stress here is that for these new platforms, the threat landscape doesn't change. So we still have to worry about opportunistic attacks, target attacks. We still have to worry about patching our systems, etc. So it doesn't really matter which platform, the threat landscape remains the same. However, some of the security issues change for these different platforms itself, and we're going to take a look at a few of those. And the goal is, and we're going to see by introducing some of our solutions here, is that we want to integrate security across all three of these platforms, and we want to have it done from a single management console. So it doesn't matter if you're doing security for your physical, security for your virtual, or for your public or private cloud, that the security can be managed from one central interface. What we've done is we've mapped these security issues to the different stages of your journey to the cloud. And so those stages are the IT production, business production, and IT as a service. And as you can see, as you make the journey to the right-hand side, there's additional security risks that you need to consider. So we're going to take a look at a few of these. We won't go through them all, but we're going to take a look at a few. And some of them actually don't come into play until you get further along in your virtualization journey. So for example, the first one we're going to talk about, resource contention. You don't normally see that when you start to virtualize. You only see it when you start going for higher consolidation ratios. So some of these security inhibitors or security risks, again, you only see as you start going, as you start making your journey further across to the cloud. And as you can probably see by some of these at the beginning, has to do more with the virtual machines, their operating systems, the applications on them, about securing those. When we start going to the public cloud, and it has to do more about the integrity of the data itself. So having to do more about securing the data. So what we're going to be looking at as well is how security solutions which are virtualization aware allow you to get greater operational efficiencies and make better use of resources compared to using traditional security solutions. And when we say traditional security solutions, what we're normally talking about is using security that was made for physical systems, and antivirus software is a good example. So you installed antivirus in your physical servers and your physical desktops. Well, why not just do the same thing with your virtual machines, whether it's desktops or servers? And there's some problems there that we'll talk about. When we talk about traditional security from a networking point of view, we talk about on the LAN itself, installing IDS, IPS systems or firewall systems. And there are some shortcomings with that as well, too, when it comes to our virtual environments. So again, we're going to just take a look at a few of these security issues and then introduce a solution that's actually going to address those. Now, the very first one I said was resource contention. Resource contention is something that you don't normally see when you start your virtualization journey off. It's something that you see when you're trying to get higher consolidation ratios. And a good example of resource contention is when you're using the traditional antivirus. So you're installing the traditional antivirus in each VM. The problem is that it doesn't realize that it's sharing resources. So when you take a look at different functionality that traditional antivirus has, one of them is a scheduled scan. So as the slide depicts here, at 3 a.m. in the morning, all the antivirus at the same time tries to actually do a scheduled scan. They're all fighting for CPU resources, they're all fighting for memory, they're all fighting for disk I/O, and they can have a real impact in the performance of the hypervisor itself. to the point where in some cases it can call intermittent denial of service to some of the virtual machines running on that hypervisor. So resource contention happens when we're using traditional security solutions, in this case security solutions, inside the hypervisor. So it's not only a scheduled scan, think about pattern updates as well too, and think about it in a virtual environment when you're doing virtual desktops. So first thing in the morning, all the users come in, access the virtual desktops. They have antivirus scanning in there. The very first thing that's going to do is try and do a pattern update. So suddenly you have all these desktops, virtual desktops, trying to do a pattern update and causing network storms. So they have to be, traditional security has to be adapted so it understands that it's working in a virtual environment and will play nicely in such environment and share resources. One of the other problems is the instant on gaps that happen with virtual machines. So a physical server can have really two states, on or off. Where a virtual server can be on, off, it could be suspended, it could be rolled back to previous states and time. Well, the problem is the security posture of that virtual machine. If that virtual machine becomes dormant, and you're going through a patch cycle and patching, how do you make sure its patches are up to date? How do you make sure its pattern files are up to date from an antivirus point of view? Because as soon as those virtual machines are instantiated, its security posture is going to be out of date. How long that machine is vulnerable depends on how long it takes you to bring the pattern files up to date if you're running antivirus, patches, bring them up to date, especially if it's gone from a previous state, configuration, etc. So the instant on basically says for a dormant VM that's been off for a certain amount of time and is instantiated, or from virtual machines that are instantiated from a template, and maybe that template was built before the latest patch Tuesday by Microsoft. So there are vulnerabilities already inherent in it. Once that becomes instantiated, how long does it take you to bring that security posture of those virtual machines up to where they should be? Because until you do that, they're actually vulnerable. Then something with virtualization as well too, which is known as the inter-VM attacks. And that just has to do with inside the hypervisor, we have a mini network. And we have, for example, switches. And you have a virtual machine in that hypervisor attached to one port on a virtual switch that wants to speak to another virtual machine on that same hypervisor on another port on the same switch. Well, just the way that the 802.1 protocol works, that traffic will never leave the virtual switch, so it will never leave the hypervisor. So if you're requiring or you're relying on your LAN-based networking devices to actually secure that traffic, to apply policy to that traffic, well, they won't see that traffic, so they won't be able to do it. They won't be able to apply firewalling rules. They won't be able to apply, if you're doing IDS, IPS, they won't be able to apply IDS or IPS to that network traffic. So they'll be blind to it, and hence the inter-VM attacks are blind spots. And it's just the way, again, the protocol works. If you're on one port on a switch and you want to talk to a computer on another port on that switch, the traffic won't leave that switch. Now you can do things like set up virtual LANs. You can put each one of those virtual machines onto a virtual LAN itself in order to get that traffic out so it can be inspected, policy can be applied, and then pump that traffic back into the virtual machines. And that leads to a few problems. The first one is what VMware calls VLAN sprawl, because now you're setting up all these VLANs in order just to get that traffic out of the hypervisor. And also performance bottleneck, because you're getting all that traffic out just to inspect it, to pump it back in. And a way that a lot of people deploy their machines, especially in a multi-tier, if they have their web application server, their application servers, and their databases, they tend to all put them on the same hypervisor. So in order to get that traffic out, we need to do something special with it. Otherwise, our LAN-based networking devices will not be able to apply security policy to it. And just overall, complexity of management. VM sprawl is so easy. It's so easy to instantiate new virtual machines. But making sure the security state of all those virtual machines is up to date can be a challenge for a lot of operators of the virtual environment. So complexity of management, inter-VM attacks, instant-on gaps, and resource contention, these are some of the challenges that organizations face as they start to virtualize. And during their initial virtualization projects, they don't usually are concerned about this. A lot of organizations that started their virtualization products didn't involve security. Security was not contacted. So it's usually during the more advanced stages of virtualization, in the business production stage, where organizations start to run into some of these issues. So we have a product called Deep Security that is a virtualization-aware security solution that's used to address these concerns and some of the other ones that I haven't gone into. Now, Deep Security has been around for about 10 years, and we've been using it. It's a host-based security solution, and we've been using it to secure physical servers. We've also been using it for the past 3 years to secure virtual machines as well. And with virtual machines, we have a choice. We can either secure them by installing an agent or by actually protecting them agentlessly. And I'll talk more about the agentless protection in a moment and how it uses better use of resources to get us out of that resource contention problem that we're talking about. So Deep Security, again, it's a host-based security solution. It's been around for about 10 years, and it's been protecting virtual machines as well as physical servers, both desktop and servers, I should say. And it has 5 pieces of functionality that it incorporates in one product, one management solution that goes across all platforms, physical, virtual, and cloud. The first piece of functionality is deep packet inspection. And deep packet inspection is a technology that's used for performing IDS, IPS, web application protection, and application control. So when we say IDS, IPS, we're basically monitoring the network, looking for malicious activity, such that activity is trying to exploit a vulnerability in an OS or running applications on top of that OS. So we support multiple OSs, multiple applications, etc. And a lot of our customers use that functionality for providing vulnerability shielding or virtual patching. And what I mean by that, to give you an example, we support the protection of Microsoft products and others, but we're also part of the Microsoft Active Protection Program. So on Patch Tuesday, when Microsoft comes out with its security bulletins, within 2 hours we have our rules in place. Now, those rules can then be used to monitor the traffic to see if there's anything trying to exploit any of the newly released vulnerabilities, either in the OS or the running applications. So even if our customers can't apply the actual patches, we can still apply the protection until they patch. And I'm not sure in your areas how much different compliance comes into play. But in the UK where I'm based, PCI compliance is on top of a lot of organizations' minds. And with PCI, it requires that they patch their critical systems within 30 days. And a lot of our customers can't meet that 30-day window. So what they do is they've worked with their auditors to use this as a compensating control. So although they can't provide the patches within 30 days, they monitor their network, trying to see if anything's trying to exploit the vulnerability that patch applies to, and they use this as a compensating control in order to stop that. Obviously, their auditors have to write off on it, but that's sort of the use of the IDS IPS. We also do web application protection. And with web application protection, we're basically monitoring web application traffic for things like SQL injection, cross-site scripting, or other vulnerabilities that affect web applications. And with the application control, again using the deep packet inspection technology, we do protocol analysis. So we can see what applications are accessing network and actually tell you about it or reset the connections. Maybe you have a policy that users should only be using Internet Explorer, for example, and you find someone's using Google. Well, what you can do is you can actually alert on that or reset the connection and take whatever action that you want to do. Or maybe someone's running a rogue HTTP server from their server. So these are different things that the application control will get you. That's the sort of the first security functionality of Deep Security. We also have a stateful bidirectional firewall. We do log inspection. If you're familiar with the OSSEC project, OSSEC, we acquired it about 2.5 years ago, and we have the OSSEC engine in the Deep Security. And what the log inspection does is it basically parses logs looking for interesting security events. You can find all sorts of things in logs. You can find SQL injection attempts in logs. It's actually quite a rich functionality. And again, a lot of compliance requirements, and PCI being one of them, requires that organizations monitor their logs on a daily basis. Well, that's what this functionality is for. It's basically to monitor the logs, looking for any interesting security events that it should be reporting on. And then integrity monitoring. Integrity monitoring, we're monitoring the systems, looking for changes to files, to directories, to services, to processes. And the idea behind that is we're looking for any indication that the system was changed either maliciously or unintentionally, and the security posture of the system is in question. And then last but not least is antivirus. So these are the 5 pieces of functionality that deep security has. Again, we've been applying this against physical servers for about 10 years, and we've been doing virtual servers for about 3 years. But the interesting part about virtual servers is we can do this from an agentless fashion. So in other words, we don't have to install software inside the virtual machine in order to get most of this functionality. And the way that we do that, I'll explain in the next slide. But first, I just wanted to give you a high-level overview of deep security. So it's client-server based. We have the server up here, our deep security managers. It speaks to a back-end database. The clients themselves, we support a very heterogeneous environment, so Windows, Linux, CentOS, SUSE, CentOS, Solaris, both the x86 and the Spark architecture. We have some support for HPUX, HPUX, and AIX. And then for virtual machines, we can either install an agent or we can protect the virtual machines without having to install an agent by having a security virtual machine do the protection. And I'll explain more about how that works in the next slide. One of the key here is, though, that we integrate with vCenter. And what that means, as soon as we see a new virtual machine created in the virtual infrastructure, we can automatically protect it. So we're event-driven. We get an event from vCenter saying a new virtual machine has been created. We can then automatically protect that via the security manager. One other thing that gives us as well, too, we can also support vMotion. So if a virtual machine is going to migrate from one hypervisor to another, we can make sure it's protected. And when it lands on the new hypervisor, it's being protected again with the same security context. So with migration around, the security context is now tied to the virtual machine as opposed to a security context being tied to an IP. The other thing that we get is the virtual machine is destroyed. And that becomes really important when you start talking about virtual desktops. Because in virtual desktops, normally they're non-persistent, which means at the end of the day, when the user stops using that desktop, it's destroyed and it's gone. Well, if your security solution doesn't integrate with your virtual infrastructure management interface, it means it doesn't realize that desktop's been destroyed. And you'll see a lot of offline virtual machines. And you won't know, are those virtual machines offline because they no longer exist, or are they offline because they're just really offline? Because we integrate with vCenter, we always know the exact state of the virtual infrastructure and the exact level of protection that's on each one of those virtual machines. So from an operational efficiency point of view, integrating with vCenter is important to understand the state of the virtual infrastructure and not have to do anything manually. So how do we do the agentless protection? Well, we can do that if you're using vSphere. So if you're using VMware's hypervisor, we can do that. Because VMware allows us to tie into what's known as their introspection APIs. Currently, they're the only vendor that allows these APIs, I should say, that has these APIs that can be utilized. So the first API is the VMsafe API. The VMsafe API was introduced with ESX 4.0. And what it does is it allows us to get access to the network traffic that's going to the virtual machine without having to reside in the virtual machine. So this is still host-based protection, but it's host-based protection being done off the host itself, being done centrally by security virtual machine. What that allows us to do is inspect the traffic, just as if we were in the guest virtual machine, but outside, and apply the deep packet inspection. So we can do the IDS, the firewalling, the web application control, the application control, etc. We can do all that as well as web reputation as well too. What the web reputation is, if a service or a user are going to a URL that's known to be malicious, we can reset that connection as well too. And so we can do that all agentlessly, and this is all can be turned on or off depending on what you want to do. We can do this all agentlessly, again, because of the introspection APIs that are found in the hypervisor. The other thing that we can do agentlessly is the anti-malware. So the antivirus capability can be done agentlessly as well too, because of the endpoint security APIs. So there's two sets of APIs that we integrate with. One's the VMsafe APIs, The other ones are the endpoint security APIs. The endpoint security APIs allow us to see which files are being accessed by the user or the service in the virtual machine and do the malware lookup. So what this gets us as well too is that as soon as this guest virtual machine comes online, we no longer have to worry about it going to get a pattern update, because the pattern updates aren't kept in the virtual machine. They're kept here in the deep security virtual appliance, or the security virtual appliance on the hypervisor that provides the protection for all the guest VMs on there. So instant on, the security posture will be up to date because, again, the security posture is not kept from an antivirus point of view. The security posture is not kept within the guest virtual machine. It's actually kept and enforced by the deep security virtual appliance. So that's kind of a high level. I'm not going to go into too much more detail on that. Again, we have our security virtual machine here. We have our guest VMs here. And then we have our vCenter vShield Manager. vShield Manager is what's used to actually manage the vShield endpoint. So the vShield endpoint is basically the middle layer within the hypervisor that vendors like ourselves integrate into in order to provide the agentless anti-malware. Endpoint Security 2.0 was released about 2 or 3 months ago by VMware. So not only can we do anti-malware, but we can also do agentless integrity monitoring. So we get access to enough of the system where we can actually monitor the files for any changes and then report on those changes as well too. So integrity monitoring, again, is what a lot of organizations are doing either for internal compliance or for external regulatory compliance as well too. So for network protection, we need nothing in the guest VM whatsoever. For anti-malware protection, we need to have the VMware tools definitely installed within the guest VM. And part of the VMware tools installation is optional, is the vShield guest driver. So the vShield guest driver is a VMware driver that's installed as part of the VMware tool, installed with the VMware tools. So that's how we do the agentless anti-malware protection. Just to give you an idea of the resources used agentlessly versus agent-based, this was a TALA report that we commissioned when we first came out with the agentless agentless anti-malware, showing percent baseline versus doing nothing with doing anti-malware, both from an agentless point of view and an agent point of view. So we can see that we get better use of CPU resources, RAM resources, and disk I/O as well too, going agentless than versus agent-based. And this is what gives us the higher consolidation ratios. We're then able to put more virtual machines per hypervisor because in fact we're using less resources now inside each virtual machine. So if we look at it this way, we've removed the security from the virtual machines, we've centralized it. It allows us to get more virtual machines per hypervisor, and it also allows us to not only do antivirus, and again, the pattern updates are kept within the virtual machine, so you no longer have to worry about pattern update storms, especially in a VDI environment. And because we integrate with, and we also do, again, from an agentless point of view, integrity monitoring, and then we also do the agentless network protection as well too. So, resource contention problem. So from a resource utilization, it's much better to actually do it from outside the virtual machine as opposed to inside, and that's why VMware introduced these APIs, and that's why we integrate with these APIs as well too. If you still want to run an agent within the virtual machines, you still can. The agent itself is virtualization aware, so it realizes it's running in a virtualization environment, and it will use resources accordingly. But the other thing to think about as well too is not just the resource utilization, but as the operational efficiencies. And I pointed this out already. We integrate with the virtual infrastructure in case of vCenter, so we can protect a virtual machine as soon as we see it's been instantiated. We also remove it from the security manager as soon as it disappears. And we can protect virtual machines as they migrate from one hypervisor to another hypervisor. Now, one thing that I wanted to quickly point out, and I'm running out of time here, so I'll go through this quickly, is that when we're making the journey to the cloud, we talked about protecting the virtual machine. So we talked about protecting the OS and the applications. But when we start going to the cloud, it's now more about data, actually the protection of the data itself, the integrity of the data, the confidentiality of the data, the auditing of the data, who's accessing it, and the destruction of the data, all in a multi-tenancy shared storage environment. Just to quickly go through this, and some of the concerns would be You're putting the data out there in a shared environment. Well, who else can actually get access to that? And data in public cloud environments tends to be quite mobile as well too. So how do you know where it is? How do you know who else is accessing it? Whether it's staff of a cloud service provider, whether in a multi-tenant environment, it's another tenant there. And we also have a solution for this, which we call Secure Cloud. And Secure Cloud's based on encryption. So what you want to be doing is obviously using standard-based encryption. Encryption itself is not difficult. The hardest part about encryption is key management and making sure that you manage the keys, that you can get access to the keys when you need to, you can roll over keys, you can destroy keys, and that when you generate keys, they're done in a secure fashion. So key management is actually the most difficult part. But the idea behind encryption as well too is that, and the releases of a key, is that you get audibility back for your data. Because the data is encrypted, the only time it can actually be accessed if a key is released. Well, you can actually start monitoring now and auditing when a key's been released, who it's been released to, when and where. And sorry, just in the interest of time, I will go to the last slide here. So, and how Secure Cloud works. And again, it's made for cloud environments, both private, where you want to keep data separate from one business unit to another, as well as public. And that virtual machines, when they go to mount an encrypted drive, they'll request a key to be released in order to access that information. So what's unique about this solution is before we release the key, we identify the virtual machine, where it's running, to make sure, for example, it's running in Europe as opposed to running in the US, IP, the location, the time, etc. So they're identifying the server, but we'll also do an integrity check of the server as well too. What ports are opened? Antivirus patterns, is it up to date? It will also integrate with deep security as well too to make sure the integrity of the system is such as it should be. So we have different rules in place to make sure the integrity of the system is fine before we actually release the key, as well as identifying the virtual machine. We'll also do ongoing checking as well too. So if that virtual machine were to have been compromised, we can then revoke the key as well. Okay, so deep security and Secure Cloud are two of the solutions we have for virtual environments and for your journey to the cloud, and basically addressing a lot of the security concerns that we have here. We have papers at our booth if you're interested in more information on this or even want a demo of it as well too, we can do that. Appreciate your time. If you want to hand in your surveys now, what we can do is collect them. And again, we have 2 USB tokens which we're going to draw for anyone who has them. If you can hand them to our colleague over here, that would be great. Okay, thank you for your time.